Hello everyone, welcome to CrossML AI Insights. My name is Prabhjot Singh and today we are going to discuss how RAG transform language models. And with me it's Sunil here from data scientist team and he will give us overview of RAG, its components and advantages. So welcome Sunil.
Thank you, Prabhjot. It's pleasure to be here.
So as we know, RAG is an AI framework for retrieving facts from an external knowledge base to ground LLMs on the most accurate, up-to-date information and to give users insight into LLM's generative process. So can you give us an overview of like what is the purpose of RAG and what are the components of RAG? How is transforming the language models?
Basically, when we develop or design any generative AI systems, so typically we are customized, or when we ask any question to our LLM, so we need to customize is by getting some responses that is specific to our context. So by uh, by customizing, it means we use different techniques like prompt engineering, RAG retrieval, augmented generation, fine tuning, and also pre-tuning. So in our discussion, we will discuss up to the RAG techniques.
Okay. Great. So there are key components of RAG that are including document encoders, generation models, retrieval mechanisms. So can you give us an overview on that also?
Yeah, there are there are two main component of retrieval augmented generation. That is one is retrieval based model and another is generative based model. So in retrieval based model, there is lack of ability to generate a creative or novel content by the LLM when we ask or give any prompt to the LLM. And in generative based model, we need to train our LLM on the use a massive amount of large amount of data, and then our LLM learn these patterns from these data as the insights using natural language processing technique, and after that he will predict the relevant or context related text to us.
Okay. So great. So there is a component named document encoders also, right? So what is that like? Document encoders I have read is used in RAG to encode retrieve documents into latent space for better representation. And how does it work actually?
Basically, encoders play important roles to our AI generative systems because encoders means when we train our model or when we ask any question to our LLM, then encoders, it's nothing just convert our text into a numerical representation. For example, like I have a sentence like I am a boy, so we encode them into the numerical like I some numerical values like 0, 1, or any numerical value that can understand by our computer or the machine. By converting these texts into the binary or numerical format, we have some different types of techniques like bag of word techniques, TF-IDF, word to word embeddings, word to vector. So in bag of words, what we do basically in bag of words, as I give you the example, like I'm a boy, so we need to encode the I into some numerical values. But these numerical value we can represent into the vectors format, and uh, and these vectors encode as a one hot encoding. So and as we term the next technique is TF IDF. TF means term frequency and IDF means stand for inverse document frequency. So term frequency means suppose we have a one paragraph of text paragraph in text. So, like we found some particular word. So, how many times it repeat in that sentence, and we count the total number of frequency in overall all the paragraphs, which will be called as a corpus. So after that, when the number of times the occurrence of word, we represent it to the numerical format or vector format. So similarly, these techniques are some advantage and disadvantage. Uh, so out of these techniques, we found the best technique word to vectors. Basically, these words we can measure into we can represent into the vectors like format, and all these embeddings are used to develop a new models called embedding models, like as you've seen as the Google embedding models, Hugging Face embedding models, OpenAI embedding models. So these are the different models today we are used.
Okay. Thank you for that information. And I was also reading a survey that LLM demonstrates significant capabilities but face challenges such as allocation, outdated knowledge, and non-transparent, untraceable regional processes. But RAG has emerged as a promising solution by incorporating knowledge from external databases. This enhances the accuracy and credibility of the models. That also allows for knowledge updates and integration of domain-specific information.
Yeah, as we know about the retrieval augmented generation, so what basically RAG is a technique in the natural language processing to ask a question from our large language models by giving one shot or few shot inference. So basically, RAG comes into play where when our model cannot capable to answer such kind of event, like if I ask the question to our LLM, like what is the revenue of our company by this year, so it tells us it doesn't have enough information about it. So, and if we ask, can you book a train to Delhi? So it can't able to do this because they doesn't have up to knowledge and some kind of uh, these. So here the RAG is come into the play so that we can so that we can so that we can uh, get a relevant and context specific output from our large language model. So basically in this technique, uh, uh, suppose here if you see in the diagram, so suppose there is no RAG. So when we ask a query to our LLM model, so simple by giving prompt. Prompt, basically what is prompt? Prompt is a technique for structuring and structuring the text into the natural language into the natural language processing technique uh, that can be understood or interpreted by our LLM model, and then get response according to our query or instruction. So uh, suppose whenever we ask question like our what is the revenue of our company by this year, so these data or these information are not available into our knowledge of our LLM that can be trained on previous data set. So we need to manage, we need to create a kind of knowledge base, or you can say that a database from which can took this type of information and get the response relevant to our query.
Yeah. That was really helpful and informative. And I was also checking there are very good real world applications of RAG models, and RAG models have demonstrated versatility across multiple domains. So there are applications like advanced question answering systems, content creation and summarization, information retrieval, conversation agents, and chatbots. I think it will be good to discuss these uh, applications of the RAG models.
Yeah, there are various application of RAG, question answering system, text summarization, dialogue system. In question answering system, basically, suppose you have your PDFs and some other data sources, and you want to ask anything from inside this PDF, then it can help you by saving your time and many more. So in question answering system, just giving your PDF to the LLM, and LLM can respond relevant to your query. And in text summarization, suppose you have a large amount of text or from various sources, like like you want to study some other resources from the internet, so you want to give the URLs and these text to the our LLM or our RAG system, then it can be summarized into some very specific and relevant text or answer you basic. So that that is much less time consuming and faster results you will be get of this text summarization, and that can be save your time. In dialogue system, suppose the conversation of between two or three persons are there. So some of like important only you want to eager to some important information about these conversations, so it can be extract or summarized to for you. So these are the various applications which will very nowadays improve in our daily life.
Yeah, thank you for that. And I was also checking the benefits that it provides a lot of benefits, like better context understanding, enhanced user interaction, and it also including improved response quality. I think that are the perfect benefits that we can get from our AG models.
Yeah, of course, it's a lots of benefits over our traditional large language model AI systems, because our traditional approaches or systems are struggling with getting some latest information or uh, accurate result. So these are overcome by this RAG system. So including like improved response quality, uh, as we discussed previous, our large language model don't have capability to fetch accurate result from our PDFs or any paragraphs. So as discuss, RAG is much faster and give accurate result on our query. And after that, uh, it also get a better quality response, as well as better in specific context, like in what context you ask, or what kind of answer you get, it is which is very accurate. And so whenever you get the specific or context relevant answer from our large language model, then automatically your interaction are very good for these systems. If our large language model or system cannot answer your specific or relevant response, then you will be bored, sometime bored from them.
So, are there any specific strategies that we should keep in mind while implementing the RAG?
Yeah, whenever you whenever you whenever you go or implement these type of rack system, there are some basic steps to be follow, and some frameworks are also there, some open source also there to be implement this. So basically, what are these steps to implement it, our rack system? Basically, if you see in this figure, the first step is document loading. So document loading, what does it mean? You have various sources. like you have a PDFs, you have a internet sources, you have links, you have YouTube videos, you have LinkedIn videos, many other, and you have also a database. So you all need to combine all the sources into one. So in first part you can get the chunks of data, or you can huge amount of data from various sources from the internet, and uh, as I told you earlier. After that, whenever you collect all the data or from the different sources, these sources are much huge that cannot be accept our LLM or the computer in a single shot. So we need to uh, these these texts into a smaller chunks, like by splitting into smaller chunks. So in second step, our collected text you want to break down into smaller chunks. So whenever it converted into the chunks, we need to store them uh, into the database, or you can say that you can make a knowledge base where from where your LLM can pick the knowledge and give the relevant or contextual answer to you. And so this storage you will for by this for this use this storage you can use the vector store databases like ChromaDB or the ChromaDB FAS vector store, and Pinecone, which is very trending in nowadays. And these are the vector database. You can use any of vector database for making the knowledge base for our LLM model. And after that, when you make your knowledge base, then you query to the our LLM model. So when you query our LLM model, we need to create a chain. So these systems can be developed by open source framework like LangChain. So in LangChain, it will create a chain for retrieval answer. So whenever you query, then it asks to our vector store or knowledge base. Knowledge base, it may be our internet, the whole internet, or current third party API. So by this making a knowledge base, you can up to date knowledge, so that our LLM cannot be cut off knowledge and don't reply the answer, I don't have enough knowledge about this. Then after that you can be deploy in any of according to your use case, like question answering, as we see the application of RAG. So these are very uh, yes.
Yeah. So it become crucial to address the challenges and limitations that these innovative systems face, despite their groundbreaking ability to merge parametric and non-parametric memory for enhanced language generation. RAG models are not without their hurdles. This fifth installment aims to shed light on these challenges, offering insights into complexities of RAG models and on the ongoing research aimed at overcoming these obstacles. So I think that there are a lot of challenges and limitations for the implementation of RAG.
Yeah, I agree with you, Prabhat. As we see the challenges and limitation to develop such kind of track systems, basically the first challenge that we faced in our developing these kind of systems, like scalability issue, because the huge model which is trained on huge massive amount of data set, like 70 billion parameters and uh, uh, 7 billion parameter or trillion parameters. So specifically, we need to scale them, and we need to uh, um, inference time of our models response. So ultimately, the scalability is a big challenge, and the model biases is also main challenge. Like when we ask any question to our model, so when we ask a question to our model in some context, and it can reply to us in some other context. So these system facing much time for model biases, and the hallucination or play major important role, because these AI systems are not much like as much like human beings can taste, smell, and they have a feeling. So our model cannot interact these things, because these things are actually are real, like taste, smell. Uh, these are placed in our mind, but the AI system or RAG system cannot be interpret these type of technique or data. You can say that. So the hallucination is major challenge here, and the data quality concerns, yes, also, like they can be a search like a semantic search or similar kind of search, uh, but sometimes there are two responses which can be very similar kind. So uh, in this case, our model can be give a false result to us. So these are the very much challenge for developing our LLM models or
Yeah.
that system.
Right. And what can be the future directions for RAG?
Yeah, future directions are to there need to overcome these type of challenges, and we need to advancements in the architecture of our rack system, that that are that that to be give response like very fast and accurate, relevant to our context. So basically, the architecture play important roles in the future for our rack system. Like we have changed some technique, like we have some hybrid querying, increase model inference time, and these I think these techniques play a major important role for the futures of the rack systems.
Right. Thank you so much, Sunil, for this information. I think that's a very helpful, that will be very helpful for the people who are researching for RAG models. Uh, content. And in the end, I think we can say RAG represents a significant leap in the evolution of language models by combining the power of retrieval mechanisms with sequence-to-sequence generation. RAG models are providing richer, more detailed, and contextually relevant outputs.